Okay, so in this video, we will be discussing a few programs from Java, function overloading, as well as functions in general. Now let's start off with the first one. We have been asked, if you look at the first question here, I'm talking about this one, the one which I've highlighted. So we have been asked to create a class with the following methods. So we have been asked to create two methods in a class. One is called largest, which returns a value of type int and takes in two integer arguments. And we have another function called call, which has a return type void and does not take any argument. Now the largest function finds the largest number or finds the largest integer between a and b. It will take in these two arguments a and b and will find the largest between them, and it will also return the value. It will also find the largest number and return the largest number. Now the call function that you can see here will input 10 integers, and using the largest function, it will return the largest among 10 integers. So let's see how we can go about doing this. So I'll quickly turn to my notepad file, but before doing that, what I'll do is I'll just copy this question so that we can have a head start. I'll copy this question and I'll paste it here in my notepad file, and I'll comment it out, right? I'll comment it out so that we can take occasional glances. Now let's just save this file. So I'll save this. So let's just call this file sum largest, or let's just call it largest. Let's just call it largest dot java. Yeah, and there you have it. The syntax highlighting has been permitted now that we are in a Java file. Let's create a class. We'll name the class largest, and we'll write a method. But before writing our methods, we need to accept user input, don't we? Yes, we have to accept input. Now see, there is this call function. It will input 10 integers, and using the above function, it will find the largest among the 10 integers. Okay. Now the largest function, if you see, it takes in two arguments, and we have to pass one argument at a time. So what we can do is we can pass two arguments at a time to the largest function and keep on finding the maximum. So let's see how we can go about doing this. The first thing that we write is, we'll just define these methods for ourselves. We'll first define the largest method, or maybe we can start defining the main method first. Okay, so let's just define the main method. So public static void main, and we need to specify the command line arguments using this array args, an array of strings. Also, we need to import the scanner class from the util package. This will enable us to accept user input. Now what we'll do is we will simply call this function call. There's this function called void call. Now in this function, the 10 inputs will be taken from the user, and using the function above, that means using the largest function, we'll find the largest among the 10 integers. So this main function will have only one job, and that is of calling the function called call. And since call, as you can see here, the return type of call is void, that's why this function will not return any value. So in the function call, I simply write the name of the function. It's not taking in any arguments. That's why the argument list is empty, and it's not returning any value. Because it has a return type of void, it's not returning any value. So the function call, this is the function call. The function call has nothing on the left hand side. If the function had a return value, then we would have had to write a variable on the left hand side of the function call. So this is my function call statement. So this is what you call the function call statement. So the function call statement is written according to the function description that is given to us. Okay, so as you can see in the description of the call function, it takes in no parameters and it returns no value. That's why the call function statement is something like this, which is not passed any arguments and which does not return any value. Now moving on, since main is static, right? The main function is static. That's why it can invoke other static functions. As a result, we need to ensure that the call function is also static. So we'll say static void call, right? And we'll move on. Now you can see that the return type has to be void because it does not return any value and it does not take in any arguments. So the parameter list is empty. You can also add the access specifier public. Later on, in videos on classes and objects, you will see why we use public and when we should use public and when we should use private or when we should use protected. So you'll see the differences later on. But for now, remember that when you use the public access specifier, public is known as an access specifier. This public keyword is called an access specifier. You will use this access specifier when you want your function to be available to all other functions within your class as well as to all other functions outside the class. Okay, that is when you use the public keyword. Okay, now in this call function we need to input 10 integers. Okay, so since we have to make use of the largest function, which takes in 2 arguments. We will accept 2 inputs at a time in the call function and will invoke the largest function. Okay, so let's see how we can do this. So we say that scanner, let's just first create the scanner object. Scanner scan equal to new scanner system.in. Now after this, what we'll do is we will write a loop. Of course, we'll have to input 10 numbers. So our loop will run. Now I'm purposely running the loop 5 times because for each iteration I'll be accepting 2 inputs. For 5 iterations, then I'll be ending up accepting 10 inputs. So that's why I'm running the loop 5 times because I'll be accepting 2 inputs at a time. So I don't need to run the loop 10 times. If I am accepting for each iteration, if I'm accepting 2 inputs, then the loop might as well run for 5 times. For each time I'm accepting 2 inputs. So I'll say system dot out dot print. So in a new line, sorry about that. In a new line, I'll say enter a number, or let's make it even more clear to the user. I'll say enter an integer. Enter an integer. And seeing this statement, what the user can do is the user can enter a number and I'll accept that number in a variable called num1. So I'll say scan dot next int. The next int method will help me to accept an integer input. I'll do the same thing for accepting the second input. So I'll say enter. I'll just say enter an integer and inside another variable called num2, I'll accept the user input. Now after accepting the input, what I'll do is I will call the function largest, right? Now, an interesting thing in this question is it's saying that the largest function will return the largest between a and b, and we'll have to make use of this largest function to find the largest among 10 integers. Okay, so we'll have to call this function over and over again. We'll have to call the function largest for each iteration of our for loop. So since the for loop will run 5 times, we'll have to call the largest function 5 times. So I'll say int max equal to, or let's call it temp, and I'll call the largest function on num1 and num2. Okay, now we'll have to check whether r, the largest of these two, is greater than our current largest. That means, so I have the largest between num1 and num2, and now what I'll do is I'll check. So if I'm at the first iteration, that means if I is equal to 1, if I is equal to 1, then my max, I have a variable called max. So in my, I'll just declare this variable called max, which will store the maximum number. So when I is equal to 1, then it is my first iteration. For I equal to 1, it is our first iteration. And in our first iteration, what we need to do is we need to assign max to temp itself, because we haven't seen any number, or we haven't seen any maximum value before this iteration, because it is the first iteration, right? So in my first iteration, the temp which I get, the largest number that I get out of num1 and num2 is my max. But from then onwards, that means when I is no longer 1, I'll have to check. What do I have to check? If my max happens to be less than my temp, right? So if max happens to be less than my temp, then I need to update my max to temp, right? See, what happens here is, let's say the user enters for the first two. In the first iteration, let me write it here. When I is equal to 1 and the user enters num1 equal to 20 and num2 equal to 2. So out of 20 and 2, which is the largest? Obviously 20 is the largest. 20 is the largest. So this 20 will be stored in temp. So temp now contains 20. Now since this is, and what is max? And max is unknown, because it is my first iteration. And if you observe that max has simply been declared here. So in my first iteration, max does not have any value in it. When I is equal to 1, max does not have anything in it. So max is unknown. So whatever be the value of temp will be the value of max. That's why I'm saying that for the first iteration, simply assign the value of temp to the value of max, to the variable max. Simply assign the value of temp to the variable max. Otherwise, if I is not equal to 1, that means the second iteration onwards, there is something to check, because max now, after the first iteration, max is a value. Max is a value of 20. Now, from the second iteration onwards, what do? Is we check. We'll again input two numbers. Now, let's say the user enters for I is equal to 2. That means in the second iteration, let's say the user enters num1 equal to 12 and num2 equal to, let's say, 14. Now now what I'll do is I'll call this function largest. I'll call this function largest on num1 and num2. What is num1? 12. What is num2? 14. Now out of these two, the largest is 14. So temp will now contain 14. Now temp contains 14. Now since temp contains 14, now max contains 20. Now from this second iteration onwards, max will have a value. So I need to check whether my current maximum, see, temp contains the current maximum between the two current inputs. So I'll have to check whether the current maximum is greater than the previous maximum. Or in other words, I can say that whether my previous maximum, which is stored in max, is lesser than my current maximum, which is temp. If that happens to the, if that happens to be the case, then I need to update my max. So in this case, I can see that temp is 14 and max is 20. So max is obviously greater than 20, so no updation needs to be done. Let's say for the third iteration, num1 happens to be, sorry about that, 112, and num2 happens to be 1. Now in this case, temp will find the maximum of num1 and num2 to be 112 using the largest function. Now I'll have to check. What do I have to check? I have to check whether my previous maximum, which is 20, is it less than my current maximum, which is temp? Or let's say my temporary maximum, which is stored in temp. I can see that my current maximum, which is 20, is lesser than my temporary maximum 112. Now, since that happens to be the case, I need to update my max to 112. That means I need to assign to the variable max the value of temp, and that is exactly what I'm doing. So since max is less than temp, what is max now? Max is 20, and temp is 112, so max is less than temp, so I'll update my max to 112. So this is how you can make use of the largest function to find the largest among 10 integers. Now our work is yet to be completed. See, I'm done with the call function. Now I need to define my largest function. So if you observe the largest function, let me show you. The largest function is supposed to be in this fashion. So what I'll do is I'll simply copy that and I'll paste it over here, and I'll say static. It has to be static because it is being called by the function call, and call is a static function. So I need to invoke largest as a static function, and I'll also make it public so that it can be made available to classes and functions outside the parent class. So the largest function is part of my class called largest. Now see, the class name is largest with a capital L, but my function name is largest with a small l, and these two are different. So it's perfectly all right to use two same names to declare a function and a class, provided they are of different cases, because Java is case sensitive. Now in this case, what we'll do is we'll simply find the largest of A and B. So I'll check. What will I check? I'll check if A happens to be greater than B. If A happens to be greater than or equal to B, let's put it that way. Even if A and B are same, I'll simply return A to be the largest. It won't make much of a difference. Otherwise, I'll say return B, right? So this will take care of my largest function, and I need to make it public so that it can be available within the class as well as outside the class. Okay, now that takes care of my largest function. Now I'll try to run this. I'll save this program, and now I'll open up my prompt and I'll try to execute this. So I'll say java c largest dot java. Now the program is being compiled. Okay, there is an error. I think I missed something. So at line number 16, what did I miss at line? Okay, I missed the variable I. Now let me run it again for you. It's being compiled, and the variable max might not have been initialized. I guess we missed the initialization of max. Let's have a look. Yes, we missed the initialization of max. So what we'll do is we'll simply initialize max to a value of 0, and we'll try and run it again. So let's just compile this. Okay, so it's compiled, and now if we try to run this, what will we get? So they're asking for an integer, so let's say 13, but I don't think this will work. I think I forgot the print statement. So 15, so I think I just forgot the print statement. So I'll just terminate the execution here. I'll just give in some dummy values, because as you can see, no output has been displayed. I forgot to display the output. Now let's try to include a print statement so that the output can be displayed. So after I'm done with everything, I'll simply have a print statement. So I'll say system.out.print on a new line. On a new line, I'll say the maximum number is, and that's stored in my variable max. So I'll simply print that out. I'll try to recompile this, and I'll try to run it for you. So it's been compiled successfully. Now let me just run this. Okay, so it's asking for an integer. Let's just enter random values. Let's even enter a negative value -3, 98, 108, 6, 5. Okay, as you can see, out of all these numbers that I've entered, out of all the 10 numbers, 108 is the highest number, and that is what is being displayed in the output. So I hope this part is clear to you. Now what we'll do is we'll move on to another program. But here in the next program that you can see, we have been asked to overload a function called sum, and we have been given the description. So what I would request you to do is you pause the video for a moment and go through the question. Okay, so I hope you have gone through the question. Now here we have been asked to design three functions using the concept of function overloading. Now function overloading is used to implement one of the principles of object-oriented programming, and that is polymorphism. Using function overloading, we can implement polymorphism, which states that one entity can take multiple forms. So here you will have one function name taking multiple definitions. With this in mind, let's try to implement this class. So the class, design a class to overload a function sum. So we have the function name has been given to be sum. As you can see, the name of the function is sum in all the three cases, but the difference lies in the function signature. By function signature, I refer to the number of arguments and the type of arguments. Remember, in function overloading, the return type does not play any role. So here, what is the return type? The keyword preceding the function name. The keyword preceding the function name is the return type of the function. In the first case, you can see that the keyword preceding sum is int. So the return type is int. In the second case, the keyword preceding the function sum is double. So the function return type is double. In the third case, the keyword preceding the function sum is int. So the return type is int. Remember, the return type has no role to play in function overloading. Function overloading takes place on the basis of the number of arguments and the type of arguments, or both. So by varying the number of arguments or the type of arguments, or both number of arguments as well as type of arguments, what you can do is, and also the order of arguments, mind you, even the order of arguments plays a role in function overloading. So by varying these three parameters, you can implement function overloading. As you can see, all these three functions which have been defined with the same name sum, they are differing in terms of the number of arguments, the type of arguments, or both. So as you can see, the first case has sum taking in two arguments and both are of type int. In the second case, it is taking one argument of type double. So the first and the second cases are differing. Similarly, the second and the third cases are differing. They're differing in the type of arguments, although the number of arguments in the second and third case happen to be the same. But the type of the second function, the type of arguments of the second function is double, whereas the type of arguments of the third function is int. That's why we can say that these three functions are overloaded. Even the first function and the third function are differing. See, the first function is taking in two arguments, whereas the second function is taking one argument. So for every pair of functions, you can see that the number of arguments or the type of arguments or the order of arguments, they are differing. As a result, if we follow the instructions given to us, we can easily overload this function sum. So let's move on to our notepad and try to implement this program. So what I'll do is I'll first save it. I'll call this file sum overloading, or let's call it sum overload. So sum overload.java. And now I'll try to implement this. So I'll say class sum overload. That will be the name of my class as well, the name of my file. I'll keep it the same as the name of my class. Now what I'll do is, instead of defining the main function first, I'll first define the overloaded functions. So the first one is this one, as you can see, int sum. With two integer arguments a and b, it calculates and returns the sum of all even numbers in the range of a and b. So let's try to do this. Let's try to implement the first case. So we'll make it public as well as static for reasons mentioned previously, that since main will be calling this function and main is of type static, I need to make these functions static as well. We can have non-static functions which are also known as member functions. We'll see them later onwards in videos on classes and objects. When I implement programs on classes and objects, you will see how we can come up with non-static functions. Now here, the return type of the function is int and the function name is sum. Remember to note the capitalization. In the question, it has been clearly mentioned that the S of sum is in uppercase and we have to follow that convention. Although function names in Java are generally written in lowercase. In this scenario, we can see that the question has clearly mentioned the sum function to be in uppercase, the first letter of the sum function to be in uppercase. That's why we have to follow the convention. And it is taking in two arguments, a and b, and both are of type int. So I'll say int, and both are in uppercase. So I'll follow that convention as well. So int a and int b. Although variable names are generally written in lowercase, I prefer lowercase as well. But since in the question it has been written in uppercase, I'll stick to that. I'll not make any changes to the conventions given in the question. And we have been asked to calculate and return the sum of all even numbers in the range of a and b. So I need a variable called sum. I'll call it sum even 0, and I'll run a loop. So I'll run a loop starting from a, and it will go up to b in step count of 1. So I'll say plus plus I. And now I'll check. What will I check? I'll check whether my current value of I, whether it's even or not. If it's even, I'll simply say sum even plus equal to I, right? So how do you check for even numbers? You check for even numbers using the remainder when divided by 2. So the mod operator will generate the remainder. Now the variable is I. So if you take the value stored in the variable I, you divide it by 2, and if the remainder comes out to be 0, I'll repeat again, on dividing the variable I, the value stored in variable I with 2, if we get a remainder of 0, we conclude that it is an even number, and we have been asked to calculate and return the sum of all even numbers in the range of a to b. So the first thing to do is to calculate. So using this loop, we are calculating the sum, and after we are done with the calculation, we will simply return the sum. Now after we are done with this part, after we're done with the first version of sum, we'll move on to the second version of sum. In the second version of sum, you can see that it takes in a single argument of type double, and it will calculate and return the product of the following series. So you can see that the terms in the series are increasing by a step size of 0.2. So it's 1.0, 1.2, 1.4. So the step count in this case is 0.2. So we have to keep that in mind. So let's try to implement this. I'll use the access specifier public. I'll also make it static. And now the return type is double. And we have been asked to calculate the product. Isn't it? Yeah, we have been asked to calculate and return the product. Okay. But the name of the function is sum. Anyway, so we'll say double n. Again, following the convention given in the question, they have used uppercase for n, as you can see here. They've used the convention of uppercase for n. So we'll use n in uppercase as well. Now we need a variable called product, and its type will be double, obviously. So I'll say product double product equal to 1.0. Okay. Whenever we are doing the operation of multiplication, it's always important to understand that we have to initialize our variable with a value of 1.0. Okay. Now I'll run a loop. So I'll start with, so my loop control variable will now be of type double. Why will it be of type double? Why will I be of type double? Because if you observe, it has to increment in terms of 0.2. The step count is 0.2, and also the initial value is 1.0. So you're dealing with double terms. You're generating double terms using the loop. So your loop control variable will also be of type double. So double I will be initialized to 1.0, and it will go up to, I will go up to n, right? As you can see, it has been mentioned, calculates and return the product of the following series with one double argument. So we'll have to go up to n, right? So that's why it's lesser than or equal to n. And the step count. So the step count in this case is 0.2. Or I can just use the shorthand operator. I can say plus equal to 0.2. Yeah, that will make my code more compact. And now I'll calculate the product. So I'll say product star equal to I. So this is same as saying product is equal to product into I. For those of you who are comfortable with this shorthand notation, please go for it. And for others who have problem understanding, please, you can use this statement as well, the one which I've commented out. So this will give you the product. Now, after calculating the product, you have been asked to return the product. So I'll simply say return product, and that brings an end to the second version of sum. Now moving on to the third version. And the third version, we can see that sum has a return type of int. Okay, so we'll say int sum, and we'll also make it static, and the access specifier used will be public so that it is available outside the class as well. It's static so that main can access it directly. And in this third version, it takes in only one integer argument denoted by capital N and calculates and returns the sum of only odd digits of the number. So we have to find the digits of the number, and it will calculate the sum of the odd digits of the number and will return that sum as well. So what we'll say is public static int sum, and it takes in one argument which is of type int, so int n. Here the name of the argument doesn't matter because the n which I'm using in this case, in this function sum which I've highlighted, is not same as the n which I'm using in the function which I've highlighted above. They are different, right? The scopes are different. Since these are local variables, their scopes are restricted to the functions in which they are declared. So there won't be any problem in this case. So what we'll do is, the n here does not denote the limiting value, it denotes the number whose odd digits we have to find. So in order to find the odd digits, we'll say while n is greater than 0, till the time the value of n is not turning out to be 0, we'll run the loop and we'll calculate the digit. So we'll say digit is equal to, how do you calculate the digit? You take mod with 10. Why do you take mod with 10? Because you're dealing with decimal numbers. So the possible digits you can get are 0 to 9, and in order to generate the digits in the range of 0 to 9, you need to take mod 10. So after you're done with extracting the digit, what you will do is you will check. What will you check? If the digit is odd or not. So how do you do that? So you say if digit mod 2, so on dividing the digit by 2, if you get a remainder of 1, you can conclude that it is an odd digit. And if it happens to be an odd digit, you'll have to find the sum. You'll have to calculate the sum. So you will have a variable called sum odd, which is initialized with 0. Now, if it happens to be an odd digit, you simply sum it up as an odd digit. You simply sum it up and you store it in the variable sum odd. Now, in order to generate the next digit, what you need to do is you need to reduce your argument n by a factor of 10 so that you can move on to extracting the next digit. So how does this work? Let's say n happens to be 645. So when you do mod 10, you'll always get the rightmost digit. So the rightmost digit is 5. Now you'll check whether 5 is odd or not. Yes, if you divide 5 by 2, you get a remainder of 1. So you sum it up with sum odd. Then what you do is you do n equal to n by 10. When you do 645 divided by 10, since 645 is an integer and 10 is also an integer, on dividing an integer by another integer, what you get is you don't get the expected result of 64.5. Since you're dividing an integer by another integer, the decimal part is truncated and you're left with 64. So you were supposed to get 64.5, but since 645 is an integer, 10 is an integer, on dividing an integer by another integer, you get an integer value. So the decimal part is truncated and you're left with 64. Now when you go back up, you check that 64 is greater than 0. So your loop condition, while loop condition is satisfied. And then when you again take the mod 10 with 64, you get the rightmost digit, which is 4. Now again you check whether 4 is an odd digit or not. 4 is not an odd digit, so you will not sum it up. Then you again do 64 divided by 10. So if you do 64 divided by 10, the expected result is 6.4, but the decimal part will be truncated and you're left with 6. Does 6 happen to be greater than 0? Yes. Again you check whether 6 is an odd digit or not. It's not an odd digit, so you will not sum it up. And then again, when you divide 6 by 10, you are expected to get 0.6, but again, an integer by another integer when divided will give you only the integer part. So the decimal part will be truncated and you're left with 0. Now 0 is not greater than 0, so your loop condition is violated and you come out of the loop and you simply return the value of the sum odd variable, which stores the sum of the odd digits. Now after you're done with calculating the sums, what you can do is you can define a main method. Now this main method, so I'll write a main method for you. So I'll say public static void main string args, and I'll simply call these functions, right? So I'll call the function. So I'll show you all three cases. So in the first case, I'm supposed to print the sum of all even numbers in the range of a to b. So I'll call this function. Now depending on, so I know that the function is sum. Depending on the arguments that I pass to the function. So if I pass 1 comma 5, it will understand that, look at the function call. Now depending on this function call, it will try to understand which function is being invoked. So it will check every function. It will start with the first one. In the first case, it sees that the number of arguments is 2, and in my function call also, if you look at my function call, the number of arguments, I'll show you. Yeah, the number of arguments is 2, and the type of arguments in both cases for both arguments is int. And in the first function, the type of arguments that you see here, both are int. So there is a complete match with this function definition header. That means this function has to be invoked. The first version of sum has to be invoked, right? So if the first version of sum is invoked, we will get the sum of all even numbers in the range of 1 to 5. So I'll store this in a variable called even sum, and I'll try to print it out for you. So I'll say system.out.print, and I'll say sum of even numbers in the range is, and I'll print the value of the variable even sum. Okay. Now, if I say you call the function sum with one integer argument, let's say 557, then which version of sum will be invoked? If you observe, the version which I'm highlighting now has exactly one integer argument. This function header has exactly one integer argument, and it matches with our function call. See, our function call is passing one integer argument 557. So it matches with the third function definition. As a result, the third sum function, or the third version of sum will be invoked. So what I can do is I can simply print it out. I can print it out directly. I'll show you how. System.out.print. I can use function calls in expressions. So I can say that the sum of odd digits is, yes. So I'm using the function call. This is the function call. I'm using it directly inside a print statement. So I can do this, okay? Function calls can be used in expressions. So this is perfectly allowed. And next, what I can do is I can try and invoke the second version of sum, which I've highlighted for you. So this will take in one double argument. So if I call the function sum with one double argument, it would mean that I'm trying to invoke the second version of sum. So I'll say system, okay, sorry about that. So I'll say system.out.print. I'll say that the product of numbers is, and I'll simply call the function sum. Let's say I call it with 2.0. So what will happen is the second version, which takes in one double argument, will be invoked. So what will happen is you will simply print the product of all the numbers starting from 1 and going up to 2. So 1.0 into 1.2 into 1.4 into 1.6 into 1.8 into 2. The product of this expression will be printed. So this is how we can write our main method to invoke the functions. Now let's try to run this. So I'll open up my prompt for you. And I'll say Java C. What was the name of my class? Okay, just a moment. What was the name of my class containing the main method? So the class which contains the main method is sum overload, and the name of my file is also sum overload. When I'm compiling, I need to mention the name of my file. The name of the file is sum overload.java. When I'm compiling, I need to mention the name of the file which I'm compiling, okay, which contains my program. And I also have to mention the extension, that is .java. Now when I'm running, I need to mention the name of the class which contains the main method. In this case, the name of the file and the name of the class containing the main method, both are same, but it need not be the case always. So I'll say sum overload, and you can see that the sum of even numbers in the range is 6. So what was my arguments? What were my arguments in the first case? In my first case, I passed 1, 5. So all even numbers in this range. What are the even numbers in the range 1 to 5? You have 2 and you have 4. So 2 plus 4 is 6. So I've correctly got 6 as my output. Now what about the second case? In the second case, I'm trying to print the sum of even, I'm trying to print the sum of odd digits of the number 557. So I'll simply sum up 5, 5 and 7 and I'll get 17. And that is exactly what I've got. It's 17. And the product of the numbers. So if you open up your calculator and if you calculate, okay, I'll do it for you. I'll show you how it's done. Just to verify, just to eliminate all doubts from our minds, we'll open up calculator and we'll see the product, okay? So it's opening up, yeah. So 1 into 1.2 into 1.4, because my range was 2. If you remember, the argument which I had passed was 2. Yes. So as you can see, I had passed 2 to my function. So it will go up to 2. It will find the product of all the numbers up to 2 in step count of 0.2. So it's 1 into 1.2 into 1.4 into 1.6 into 1.8 into 2.0. So it comes out to be 9.6768. And if you compare, that is exactly what we get. Of course, we are getting a greater precision for our program. However, it works, right? So this is how you would go about doing the second program. Now let's try to implement the third program. As you can see, the third program had been asked in ICSE 2018. So again, it's a case of overloading. We have been asked to overload a function called volume with the following specifications. Again, if you observe the three functions, they are differing only in terms of number of arguments and type of arguments, or both. The return type, again, see, in all three cases of volume, the three functions that have been shown here, the three versions of volume, they all have a return type of double, but it doesn't matter. The return type of the function has no role to play in function overloading. I'm repeating it. You please note it down. So let me try and execute this program. Okay, I'm done with executing the program on sum overloading. Let's try and write the program for volume overloading. So let me just save this file first. So I'll call it volume. So it's volume overloading, or let's call it overload. And it's a Java file. So I'll say .java, and there you have it. So now what I can do is I can start writing, right? Start writing my program. So here there has been no mention of any main function, but what we'll do is, just for execution purpose, I'll show it to you. And even in your uh, examination, if you're asked this question, what I would suggest is not to include anything extra. Since they've not asked you to include the main method, you don't have to write it. If they tell you to include the main method, then you can write it. You can write the main method and invoke the three functions with sample inputs, but otherwise it's not required. So let's just go about doing this. So I'll call the class volume overload, and I'll start defining the volume function. So the first version of volume that you see marked by number 1, it takes in one argument of type double. The name of the argument is R, and here capital R denotes radius, and we have been asked to calculate the volume of the sphere with the given formula. So let's do this. So we'll give it an access specifier of public so that it's available throughout the program, and it will be of type static so that we can invoke it using our main method. So it's public static double volume. Now let's just observe the capitalization. Yeah, volume, the V of volume is in lowercase, so it's fine. And we'll take in one argument of type double, but that argument is in uppercase. Okay, fine. Now we have to simply return the volume using the formula 4 by 3 into 22 by 7 into r cube. So I'll simply say double, I'll call it vol, and I'll say 4 by 3. Now if I simply say 4 by 3, what will be 4 by 3? Again, like you saw in the previous case, I had mentioned in the when I was writing the previous program, I had mentioned that if you divide an integer by another integer, you will get only the integer part of the result. So 4 by 3, the expected result is 1.333, but what you will get is the integer part will be truncated and you will get only 1. But in this case, we need the integer part, right? We need the integer part. So what we'll do is, instead of writing 4 by 3, we can write either 4 by 3.0, or we can write 4.0 divided by 3, or we can write 4.0 divided by 3.0. What this will do is, it will simply, I'll show you what it does. Just give me a moment. So like I was saying, what happens here is, when you have, let's say if I have something like this, 4.0 divided by 3, what happens here is one value is of type double and the other is of type int. If you divide a double by an int, by rules of automatic type conversion, this 3 will be converted by the compiler to 3.0, and when you divide a double by another double, you will correctly get 1.333 depending on the level of precision. So in order to preserve the point values, we can make either one of 4 or 3 as a decimal value and then move with the and proceed with the division operation. So what I'll do is, I'll simply say, okay, sorry about that. Just to make things clear, I'll say 4.0 divided by 3.0, and I'll do the same thing with 22 by 7. So I'll say 22.0 divided by 7.0 in order to maintain the correctness of the result, and it is 4 by 3 into r cube. So I'll have to multiply the variable r 3 times. So yeah, that's what it is, right? So I'll calculate the volume and I'll simply return it. So I'll return vol, and that takes care of the first version. Now in the second case, if you observe that, we'll have to input again two arguments. We'll have to pass two arguments to the function volume, h and r, and we'll have to return the volume of the cylinder using the formula given, pi r squared h, where pi is denoted by the value of 22 by 7. So let's proceed to implement this. So we'll say public static double, sorry about that, double volume, and we'll take in two arguments. One is h and the other is r. So double h and double r, and we'll do 4 by 3 r squared h, right? It's pi r squared h. So again, we'll calculate the volume. So we'll say double vol. It doesn't matter whether I'm using the same variable in this function, because the two functions are different and I can use the same name in different functions. So I'll say double vol equal to 22.0, sorry about that, divided by 7.0. It's 22.0 divided by 7.0 into r square into h. So I'll say into r square. So r multiplied 2 times multiplied by h. After I'm done with calculating the volume, I'll simply return it. So I'll return vol. Now moving on to the third version of volume, where it takes in three arguments. One is L and the other is B and the other is H. simply multiplies L, B, and H and returns the volume of the cuboid. So I'll simply just copy this part and make the necessary changes. Sorry about that. So I'll say double L, double B, and double H. Now what I can do is I'll show you one more thing. You can use a variable. See, here I've used a variable, calculated the uh, or listed out the expression and then returned the volume. I can directly return. I can say return L times B times H. Even this is allowed. Okay. I can use expressions for my return statement. You can go with this approach as well. This is absolutely fine, where you have a separate expression and then a separate return statement, or you can include the expression in the return statement itself. After you're done, you write your main for illustration purpose. For examination purpose, again, like I mentioned, since it has not been mentioned to write about the main method, you don't have to. But here, just for demonstration, I need to write the main method so that you can understand that this program is actually working or not. So I'll just open up main and I'll call the three versions one by one. So I'll say system and I'll print them out directly. So I'll say system.out.print. The first case was, the first volume was that of a sphere. So I'll say volume of sphere is, and I can directly have the function call here. So I'll say volume, that's the name of my function, volume, and I'll pass in just one argument of type double. So I'll say, let's say I'll pass in a small value, something like 3.0. Something like 3.0 would be good, or maybe a slightly larger value, maybe 21. Yeah, 21 would be good. Okay, so you can have function calls in the print statements as well, like this. Or what you could have done is you could have written a separate statement like this, something like double vol equal to, and you would invoke the function volume 21.0. This is fine, and then move on. Instead of writing the function call, you would have simply written vol. Even that is allowed, but you would take up an extra line of code. So if you're comfortable with the approach which I'm showing now, you can go for it, or you can directly use the function call in the print statement. Okay. Now we'll move on to the demonstration of the second function. Okay. So I'll for the second function and the third function, I'll use the function call in the print statement itself. So I'll say the volume of, okay, this is sphere, and the second case, it was the volume of a cylinder. So I'll say volume of cylinder is, and I'll call the function volume. And how many arguments does it expect? It expects two arguments, the height and the radius. So I'll say 1.0 for the height and 2.0 for the radius, right? I could even write 1. It doesn't matter. It will be automatically converted to 1.0. So that doesn't matter. Or for completeness, you can write 1.0. And in the third case, in order to demonstrate the third function, we need to pass in three double type arguments for the length, breadth, and height respectively. So I'll say 1.0, 2.0, and 3.0. Okay. Now let's try to execute this function. So I'll just save it. And now I'll clear the screen for you. Try to compile it. So I need to compile it using the name of the file with the .java extension. So the name of the file is volume overload.java. So I'll say java c volume overload.java, and now it's being compiled. Let's see whether, okay, we have an error here on line number 23. So let's go there and correct it. We probably missed a semicolon. Yes, we missed a semicolon, line number 23. So I'll save it. I'll try to recompile it using the name of the file with the .java extension, and yes, it is compiled successfully. Now I'll try to run it using the name of the class containing the main method. Here I have only one class, if you observe. I have only one class called volume overload, and this class contains the main method. So I'll say Java volume overload. No extension required. Okay, you simply write the name of the class containing the main method. The name of the class containing the main method is volume overload. So you simply write that name and try to run it, and you can see that you've got the correct results. So again, for your benefit, and since I don't want any confusion to be there in your head, we'll go on and calculate. Okay, so in the first case, if you observe, the first calculation was 4 by 3 into 22 by 7 into r times r times r, and the argument which I was passing was 21.0. So let me calculate this for you. So we'll do 4 divided by 3 into 22 divided by 7, yes, into 21 times 21 times 21. And as you can see, you're getting 38,808. The decimal part has somehow been truncated, but as you can see, it's close to the result that we got here. Okay, so it should be in fractions. The fractional part here in our calculator application has been truncated, but it should be here, as you can see. Now for the volume of the cylinder, the formula that we had to use, or the formula that we used here in our program, was 22 by 7 into r square h, and the arguments that we passed were 1 and 2, 1 for r and 2 for h. So let's do that now. So we'll say 22 divided by 7. So 22 divided by 7, and we'll multiply it with r. So r is 2.0 times 2.0, it's r square, into h, and h happens to be 1.0, and this is the final result that you get. And see, it matches. The volume of cylinder is indeed 12.5714, and there are many more digits depending on your precision. And for cylinder, if you observe, we are passed in 3 arguments: 1, 2, and 3. 1 for length, 2 for breadth, and 3 for height, and we simply multiplied them to get the volume. So this is pretty straightforward, but still I'll show it to you for the sake of completion. So I'll simply multiply 1.0 times 2.0 times 3.0 to get 6, and here, quite rightly, you have got 6 as the result. So I hope these programs on function overloading prove to be useful for you. If you have any doubts, please feel free to comment in the section given below. I'll see you in the next one. Goodbye.